Example, we need to calculate three forces that apply in our project. First, that's the force in X, that's minus 5 MPa. The force in Y, that's minus 10 MPa. And the shearing stress, that is minus 15 MPa. Now we need to obtain the two angles the to obtain the force. The first angle, that is tangent minus 1, we multiply 2 by the shearing stress, that is minus 15 mpm, over minus 5, that is the exponent, minus the minus 10 mpm. That result is minus 80.53. We need to divide that by 2 and we have 40.265. We to obtain that's for the angle of P of the P. For the angle of S, we need to use the tangent minus 1, but we need to move this move the operation. We need to put the minus 5 minus 10 over 2 multiply by minus 5. It will be 9.46, and that we divided by 2, it will be 4.73. Now we need to calculate the maximum of the maximum of stress. That will be the angle x plus angle y over 2. That for the maximum is a plus and for the minimum is a minus. In this case is plus the square root of the square division of minus 5 plus minus 10 over 2, that square, plus minus 15 square. That will be giving us 7.7069 MPa, and the minimum will be minus 22.7064 MPa. Now for the Tmax, the maximum torque shearing stress will be the division, the square root of minus 10 over 2. That will be a square, that will be plus minus 15 2 square. That will result in 15.2069 mpm. And from the
In this next problem, we have as data sigma x as minus 32 MPa, sigma y as minus 20 MPa, and tension xy as 27 MPa. Firstly, we calculate two per medium angle. So we do the formula, and as a result, we get minus 77.4711. We divide it by 2, and we get minus 38.7355. Then we calculate two shear stress angle and do the formula, and we get 12.52.88 degrees. We now divide it by 2, and as shear stress angle we get 6.2644 degrees. Now we calculate sigma max. We do the formula, and we get 1.6586 MPa. Then we calculate sigma minimum. We do the formula, and we get minus 53.6586 MPa. We now calculate max tension, and we get 27.6586 MPa. And finally, we calculate per medium sigma, and we get minus 26 MPa. In this first problem, we have to first calculate two per medium angles. So we do the formula, and as a result, we get minus 77.9052 degrees. And then we divide that result So we get the promedium angle that is minus 38.95726 degrees. Then we need to calculate two shear stress angle. We now do the formula, and then we get as a result 12.09447 degrees. We divide it by 2, and we get 6.04735 degrees. Now we calculate sigma max. So we do the formula, and then we get as a result 13.76584 ksi. Then we do sigma minimum, and we get as a result minus 0.6 minus 0.66589 ksi. Or we calculate the max. We get as a result 7.1589 ksi, and then sigma per medium, and we get 6.5 ksi.
Now, for this problem, we have these values. In the x value, we have 21 ksi. In the y value, we have 13 ksi. And the shear stress in x and y, we have minus 17 ksi. We applying the formula to obtain the two angle on P, we obtain minus 76.75 degrees. And with applying the formula for two angle S, we have 13.25 degrees. Now, applying the formula for the maximum and minimum is 21 plus 13 over 2 plus the square root of 21 minus 13 over 2 is square plus minus 17 square. That will give us 34.46 ksi. The minimum, we need to substitute the plus for for a minus. That will be 21 plus 30 over 2 minus the square root of 21 minus 30 over 2, that multiplied by itself, plus minus 17 multiplied by itself. They will give us minus 0.4642 KSA. For the promet is the 21 plus 30 over 2, that will give us 17 KSI. And for the maximum shear stress, that will be the square root of 21 minus 30 over 2 square plus the minus 17 square. That will give us 17.4642. Now, with that result, we will use the angles to obtain the new positions. The first position for S will be in 6.62 degrees, and will be the promedium, that will be 17 ksi, and a positive shape stress that will be 17.46 ksi. Now we have a negative for P, that will be 38.37. We have a stress in X that will be positive and will be 34.46 ksi. We have an in Y, we have the minimum that will be a negative stress of minus 0.4642 ksi.
Hola, yo les voy a explicar el ejemplo que se encuentra en pantalla. Como sabemos, primero se obtienen los esfuerzos que se encuentran en X y Y. En X el resultado es igual a menos 12 MPa y en Y es igual a 4 MPa. Y tau XY es igual a 3 MPa Como sabemos, primero se deben utilizar las fórmulas que ya vimos en clase, las cuales vamos a utilizar de la siguiente manera. Tenemos que tangente menos 1 va a multiplicar a 2, que multiplica 3, esto dividido entre menos 12 menos 9, y esto nos da un resultado de menos 15.9453 grados. Hacemos uso de la misma fórmula, solamente que vamos a cambiar los valores, e igual, tangente menos 1 multiplica menos 12 menos 9, y esto se va a dividir entre 2 que está multiplicando 3. Esto nos da un resultado de 74.0546 grados. Para obtener el esfuerzo máximo, vamos a representarlo de esta manera, que queda menos 12 más 9 y todo esto dividido entre 2. Esto se va a sumar y vamos a utilizar raíz cuadrada. Dentro de la raíz se va a colocar menos 12 menos 4, todo esto dividido entre 2 al cuadrado, y esto va a sumar 3, que igual está al cuadrado. Esto nos da un resultado de 9.4201 megapascales. Para obtener el esfuerzo mínimo, nos da un resultado de menos 12.4201 megapascales. Para obtener el Tmax es igual a 10.9201 megapascales. Y como último, el tau prom es igual a menos 1.5 megapascales. Y esto es todo en este ejemplo.